All right. I want to start talking through this one. So we have two different competing catapults. We have catapult A. I want to write an equation for catapult A. Since it's an equation, it has to have what kind of symbol in it? Equal sign. So the height at any given time, that's what h of t means, is equal to, what would my equation for catapult A look like? Negative 16t squared. You said plus 25t? Where did you get the 45 from? You're not wrong. Just tell me where. Yep. Initial upward velocity of 45 feet per second. And then you told me to add what to this? Plus 10. Why plus 10? Yep. Starting height of 10 feet. Why did you guys pick the negative 16 equation instead of the negative 4.9 equation? Yes. Says for feet when we're talking about the height. You're absolutely right, Ralph. All right. Now I need an equation for catapult B. What does it need to start with since I want an equation? Yes. My function notation, which means the height of this pumpkin at any given time, is equal to what? Negative 16t squared plus 40t plus 25. Initial upward velocity here is 40 feet per second, and the starting height is 25 feet. So far, so good?
Yes, ma'am.
All right. Did you guys have an opportunity to get this thing graphed?
Can you show us how to do it again on Desmos?
Absolutely.
Don't you go to the wrench button and change something?
Yes. Okay, so I'm going to come here. I'm going to open up Desmos. I go to Desmos all the time. You want to click on the graphing calculator? We're going to put in our first equation. Can I put in h of t here?
No, ma'am.
I should put what equals? Y equals. And then what?
Negative 16x
Negative 16x squared.
plus 45x.
Plus 45x, no worries.
Wait, how'd you do the square? Oh, there's a key.
That button right there, yep. If you want to put in any other power, you push this one, and it lets you just type in your own power.
Okay.
And then what next? Plus 10. All right, before I put in the other equation, let's look at this guy right now.
You can't really see it.
Exactly, I can't really see it. So I'm going to go to the wrench button.
We need to zoom in.
You can zoom in and out like this, but the problem is if I zoom out, like I can see the top of it.
You can't see like.
It's like super skinny. So if I zoom out to where I can see the top of it, cool, but now I want to change my x-axis. I'm going to change my x-axis to go from negative 10 to positive 10 here, because that would be plenty to let me see this whole parabola, and that's going to stretch it out for me. So I'm going to click on the wrench. I'm not going to touch the y-axis stuff, because I zoomed out enough that I could see everything I needed to see there. On the x-axis, I'm going to change this to negative 10. And then...
What if it already is at negative 10?
let me come look at yours.
Okay.
Do you have it so that you can see the top of the parabola?
No.
Okay. Because if you can't see the top of the parabola, then what you would want to change, there you go. If you zoom it so that you can see the top, now change your x-axis. Yep.
On both of them, it's negative 10, 10.
I went from negative 10 to positive 10. You could zoom in a little bit more. Like I could even zoom in like negative 5 to positive 5.
Do we need anything for the y-axis?
I didn't change the y-axis at all.
Okay.
As long as you can see all the important parts of the parabola, you can set those numbers to be whatever you want to.
Okay.
What are the important parts of the parabola that we'd want to make sure that we can see?
The maximum.
Maximum. If it has a minimum, we would want to make sure that, does this one have a minimum, a lowest point?
No.
Why not?
It goes on for infinity.
Goes on to infinity, goes on forever. But we can see that maximum, we can see the highest point.
The
What else do you think would be important for me to see on a parabola?
the x and y intercept.
The x and y intercepts, yes. So as long as I can see all those parts, x-intercepts, y-intercepts, vertex, that's my maximum or my minimum, then I'm good. If there's anything you can't see, just play around. You can always do the zoom thing, or you can click on the wrench. Sometimes zooming makes it kind of hard to get it to work, and that's why I like the wrench. Sometimes zooming works just fine. How high did this pumpkin go? How would I figure that out?
You can click the top and that's all you know.
Yep, I'm going to click up at the top. What's the highest up this went?
41.
Yep. Little bit more than 41.5 feet, right?
Oh.
How long
Oh.
did it take to
I
do
thought-
that?
Okay. Thank you.
Yep, right about 1.5 seconds. So about 1.5 seconds, it reaches its maximum that's a little bit more than 41 feet, in between 41 and 42 feet.
Oh, you can just click on the point and see.
Yep, you can click
so
on
is
that point and
how
it'll tell you.
Answer the question, which is in the air longer?
Good question. This tells me what?
The highest point.
The highest. When would I be able to tell when it hits the ground?
When it hits the x-axis.
X-axis. So I'm going to come and click over here. Do I need both of them?
Yeah, just the farthest one.
Just the farthest one. Why do I not care about this one?
It's negative.
Oh
You
wait,
can't have
I
negative.
thought you meant both the blue and the red. 'Cause
Oh,
I put
got
my
it.
blue on there.
Yep. So this one hits the ground at about when?
3 seconds.
Yeah. Right about at 3 seconds.
Whoa, whoa, whoa. What the other one says 3-1.
Ooh. Let me type the other one in. We'll look at it at the same time. What's the other equation?
Neg y equals
Y equals
negative 16 x squared
16x squared
plus 40x
plus 40x
plus 25.
plus 25.
And then hit.
All right, I'm gonna have to.
But it looks like the red one hits first because it's closer to the x, but it's kind of hard to tell.
Okay. So we found the maximum here. Which one goes the highest?
The catapult B.
Catapult B goes the highest. It goes up how high?
50 feet.
50 feet. When does it hit 50 feet?
About 1.25 seconds.
Yep, about 1.25 seconds. It goes up to its maximum at 50 feet. When does the blue one hit the ground?
If you turn off the red one, it's a little bit easier to see it, but it's like the same thing, but like a 0.001 difference.
Mm-hmm. So you guys can turn on and off the graphs over here. So if you want to focus on just one particular thing, you can click these little dots. Yeah, looks like 3.018. If I zoom way in, I have to go way, 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 way in. Do they technically hit the ground at exactly the same time?
No.
It's pretty much a photo finish though, right? Like, I'm not even certain that the timers at the Olympics get picky enough. Let me click on this other graph. Come on. I should be able to do both of them at the same time. Come on. They're so close together. Look at the difference between those two. Not much of a difference there, huh?
Not really.
So for all practical purposes, we can say what about when they hit the ground?
About the same time.
About the same time. So can we answer the question of which one's in the air longer?
They both are in the air for the same amount of time.
Both in the air for the same amount of time. But we have a clear winner for the height, right? Which one is our clear winner on the height?
The red beam one.
Yes.
Which is, the 45 seconds.
So catapult B, which is in green here. This one goes the highest.
Like, okay, maybe not look at it.
It has a maximum of 50 feet. They're both in the air about the same amount of time. Didn't they ask me one other question? Can you find the distance traveled horizontally by each pumpkin? What do they mean by that?
Like how far from the original slot horizontally?
Yes. So basically, if I fire something from a catapult, how far that way did it land? Can I get that information from these equations, from this graph? Why or why not?
The only variables we're working with is time and height.
Yes. The only variables that we're working with are time, which is on my x-axis, and height, which is on my y-axis. It's not height and length. So what might look like horizontal distance along that x-axis there is not actually telling me how far, it's telling me how long did it take. Does that make sense? So can I answer this question here?
Yeah, you can say that.
Yep. I can say not enough info. Yep. Can't answer that question because there's not enough information. So far, so good? All right. We're going to skip page 76, but we are going to go over and look at page 77. So flip over to page 77 for me. You're going to want to stick with me for this part. I have 3 points here that are modeling a quadratic function. Which form is most helpful to write this equation and why? So let me write down the 3 forms again. We have our standard form. This was our ABC form. That's what we've been writing for all of our projectile motion equations. Y equals ax squared plus bx plus c. We have our factored, or sometimes this gets called intercept form. This curriculum calls it intercept form. That is y equals a times x minus r1 times x minus r2 and then we have our vertex form. Vertex form is the one with A, H, and K that you used a lot in Algebra 2 for all the different graphing stuff. Y equals A times x minus h squared plus k. And apparently I can't write straight without lines. That's a little bit better. Which of these three forms makes the most sense to use with the information that they gave us? I thought I heard somebody say it.
Probably the vertex one?
If I'm going to write something in vertex form, what would I want to see?
Oh wait, you need a parabola, so you do standard. We've just been doing parabolas right there, but.
All three of these make parabolas.
Oh.
All three of these make parabolas. All right, I've heard a suggestion of intercept form, factored form. And I like that suggestion. Let's look at why I like that one. What did they give us to work with?
Both of your intercepts.
Yeah, we have two x-intercepts right here. So that's really helpful if I'm wanting to write something in intercept form, because I can use one of these as R1, and I can use the other one as R2. So I'm going to substitute in. So y equals a times x minus, what are we going to use as R1? Negative 3. Well, what happens if I subtract a negative number? That's the same thing as adding it. So this is really a times x plus 3, right? And then I have x minus my other root. What's our other root? 6. So that would just be x minus 6. I don't have to simplify that at all. Is that done enough that I could call that the equation of a full parabola? How many variables does it have in it right now? 3. I have x and y, which makes sense on an x and y axis, but then I've got this a value here. I need this. How can I find it?
You can solve it by taking y and x with that third.
They gave me a third point. So I can use that third point, and absolutely, I can substitute that in the place of the x and the y that I have here. So I'm going to put 4 in the place of x, and I'm going to put negative 5 in the place of y, and we're going to reverse engineer this. So I would have negative 5 equals a. What are we putting in for x?
4.
So I have 4 plus 3. And then what goes in my other parentheses? 4 minus 6. What operation is happening between these sets of parentheses? What's happening between the a and the first set of parentheses? Multiplication. So I have negative 5 is equal to a times what? 7 times negative 2. What's a times 7 times negative 2?
Negative A14.
Close. Negative 14a. Yep. Absolutely correct. I want a all by itself. What can I do to isolate a? Divide both sides by negative 14. Negative divided by a negative gives me a positive. Can I simplify 5 over 14 anymore? Is it going to come out nice as a decimal? Then let's not. Leave it as a fraction. If it doesn't get prettier writing it as a decimal, then don't. So 5 over 14 is my a value. Do I have enough information now to write the full finished equation that I could graph? What is this going to look like then? Perfect. Can I check to make sure that that equation really does go through those 3 points? I can use Desmos to check that. I'm going to hop over into Desmos and we're going to do that. All right, so I'm going to get rid of these. I want to enter those ordered pairs that they gave me first. What were the ordered pairs that they gave us to work with?
-3, 0.
-3, 0.
6, 0.
6, 0.
4, -1.
And you said 4, -5? And if you click this little button here, it'll label those points for you. I'm still zoomed in way too far.
Starting route to Jackson.
Interesting.
Proceed to the route.
Okay then. There we go. Now I can see all 3 of those dots. Now I want to put the equation of the parabola in, and I want to make sure that it goes through all 3 points there. What equation did we come up with? Ralph, can you read it to me? Did you write it down?
No, I did not.
You did not. What do we start an equation with, though?
Equal sign.
Equal signs. Before the equal sign?
Y.
Y equals. Kevin, do you remember what we came up with for our A value?
Let's forget it. 5/14.
5 over 14. So 5 to do fractions, you choose division. After you put a fraction in, though, you have to make sure that you tell it you're done with the fraction. So you either have to use those arrow keys or you got to click outside. And then we're going to have our parentheses. What were our sets of parentheses here?
X plus 3.
X plus 3.
X minus 6.
X minus 6. Does it go through my points? Yes, it does. So we wrote the correct equation here. We have the correct A value. You guys have access to this at home. Please make use of it. Using graphing technology and graphing software is not cheating. This is another way to understand and interpret the information that we're getting from these equations. All right, down at the bottom, there's another problem. Oop, I'm going to write down those forms again and bring those with. All right, so here's our scenario. What form makes the most sense to write for this information? Ralph, I need you with me, dear. What form do we want to use on this problem based on the information they gave us to work with? Which one? Vertex. Tell me why you chose vertex. That's exactly why I would choose that one as well. They gave us the vertex of the parabola. So where do I put the vertex of the parabola in vertex form? I'm going to put the 15 in the place of what? Good guess, but no. In my equation for my parabola, I still want x in the equation because I'm going to plot those things on the x-axis. H. Where would I put the -30 then? K. H and K is the vertex. Vertex form is awesome because at a glance, I know that maximum or minimum value because it tells me my vertex. All right, so subbing in what they gave me, I have y equals a times x minus what? 15. Close my parentheses, and what do you have to remember to do here? Square it. And then what? Plus negative 30. When you add a negative, that's the same as what operation? Subtraction. So minus 30. Plus negative 30 is not wrong. We just want to make sure that by the end we fully simplify it. Do I have all the information? Tristan, you with me?
Yes,
Do I have all the information I need to go and graph this? No.
You need your, A.
Yep, I need this. How can I find it? Yeah. Y-intercept. So I'm going to put what in the place of, I don't know, what do I got? Put 25 in for Y.
And 0 in for X.
Put 0 in for X. Perfect. So I have 25 is equal to A times 0 minus 15 squared minus 30. I have to pay really close attention to order of operations here.
In parentheses, X minus. So first we do the parentheses.
First we do the parentheses. I like that. What can I do inside these parentheses?
Subtract 0 minus 15, then negative 15.
Very good. 0 minus 15 gives me negative 15. All right, so we did our parentheses. Do I have any exponents?
Yes, it's gonna be the negative 15 squared is negative 225.
What does it mean to square something?
Multiply by itself.
Multiply it by itself. If I multiply a negative and a negative together, I get positive. Your calculator will lie to you.
Oh, yeah, I forgot it does that.
Yep. Calculators will lie to you on that. So what is negative 15 times negative 15?
225.
So this is going to be 225a minus 30. What do I do next? Add 30 on both sides. Thank you, Fadiha. What's 25 plus 30? 55. So I have 55 is equal to 225a. So close. What next? What are we dividing by? 225, because I want the 225 to cancel and I want it to leave the a there. If I do 55 divided by 225 on my calculator, does that come out pretty? Can I reduce it?
Yeah.
What goes into both of those? 5 goes into both numbers.
11 over 45.
Yes. Five goes into both. So you said 11 over 45? That's my A value. Do I have enough information now to write the whole equation? What is the equation for this parabola?
Y equals 11 over 45, parentheses, X minus 15, squared, minus 30.
Yes, 11 over 45 and then X minus 15 squared minus 30. Can I check to make sure that that really is the right equation? What would I want to put into Desmos other than that equation?
The vertex and the y-intercept.
The vertex and the y-intercept. So I'm going to go over to Desmos and do that. Let me get rid of this stuff. Oops. So what was our vertex again?
15, negative 30.
15, negative 30. I'm going to make it label that point, and I'd like to be able to see that point. There we go. What other point did we have?
0, 25.
0, 25. And what was our equation?
Y equals 11 over 45, parentheses x minus 15 squared minus 30.
Does this parabola go through those points? Yes, it does. All right. Last couple minutes of class. I want you guys to practice. I'm going to give you some information. There's going to be 4 different things up here. I want you to work on writing the equations based on the information that I've given you. You might have to do a little bit of legwork, like to find an A value or something. Before the end of class, I will put the answers for all 4 of these up, but we're going to start tomorrow with the same type of activity. So even if you don't get them all, practice tonight so that tomorrow when you come in, you can do the bell work. So for A, B, C, and D, I want you to practice. I've got the 3 forms up at the top. Decide which form you want to use and substitute those pieces in. If you guys want some scratch paper, raise your hand, or you're welcome to find some free space in your book. Absolutely, Brennan. Does anybody else need scratch paper? Pass it back to Ralph. Anybody else want scratch paper? Guys, I'm going to write down the answers. I want you to take a screenshot. Yes, ma'am? I'm sorry, one more time. What's your question again? Sometimes you have to find that. Just like we had to find it as we were going through those problems together. Oh, the stretch or compression. All right, there's A. There's B. There's C. And there's D. Make sure that you can figure out how to get there so that tomorrow when you come in to do the bell work, you are good to go. Have a great rest of your day, guys. I'll see you tomorrow.